Hello, Carrie Roberts here, and last week we looked at Office application startup persistence, and for that we played with a bunch of add-ins and DLLs, and we were looking at technique 1137, subtechnique number 6, which was the add-ins, but there was also this interesting Office test technique, subtechnique number 2, and that's what I wanted to follow up on that last atomic and look at subtechnique number 2. So if we click on that, we see that there's a special registry key called Office Test. No real clear reason why Microsoft put it there, but probably for debugging purposes. So if you set this registry value to the path of a DLL, then every time you start any Office application, that DLL will run. So this provides an excellent persistence mechanism that attackers can use to get their code to run basically persistently, since Office is such a popular application, and it's very likely that every day someone will open an Office application and run that. There's 2 locations where this key can be. It can be in HKey current users, which does not require administrative access, and then HKey local machine. The things in the local machine apply to all users of the machine, and because of that, it requires admin privileges to change. So we're going to play with both of those in this atomic spotlight. And of course, in this atomic spotlight, we are going to be using Atomic Red Team. I have a tab open here to Atomic Red Team. So this is in Red Canary co-repository, Atomic Red Team. And if we look in here in the Atomics folder where the library of scripted cyber attacks resides, we see the big list of MITRE attack techniques. And we're looking for T1137-02. We look at the Markdown folder, and we are Office Application Startup, which is the technique, and then subtechnique of Office Test, this special registry key. So there is only one atomic test written so far, but today we're going to add another one. And what this test does is it creates the registry key here, HKey current user, software, Microsoft, Office test, special perf, and it sets it to a value of thing to execute, which this is a special variable syntax in Atomic Red Team, which means substitute this whole thing that I've highlighted here, the hashtag squiggly, replace it with whatever's in this table here or our input arguments. And so the thing to execute in this case is C path atomicredteam.dll. So if we emulate this with Atomic Red Team, we'll get this registry created, the registry key created, and it will be set to the path of C path atomicredteam.dll. But that's just kind of a made-up test path, and this atomic test does not even provide this DLL to us. So if we wanted to actually see this work and possibly create a detection that looks for Office spawning various DLLs, we wouldn't be emulating that part of it. We'd only be emulating the part of creating a registry key pointing to a non-existent DLL. So as we work through this atomic spotlight today, we're actually going to improve this test to work a little better. But we'll start with just using this default value of a non-existent DLL and just watch how the registry key gets set. So let's jump over here to our PowerShell window. I'm not in an administrative PowerShell window, just the standard user one. So we're going to use our execution framework for Atomic Red Team. Invoke atomic test T1137-002, and we'll show the details brief, and we see that that just prints out the title of the one and only test, a scripted cyber attack in Atomic Red Team that's written, and we can show the full details by taking off brief, and then we see everything we saw in that markdown file. We see the attack command or the emulation command here to create that key. And we see the input argument highlighted in red here, and then the command with inputs here is the same command as above, but with the input or argument substituted in. So we get rid of the red text here and we substitute in that default value from the table. Any input arguments can be changed at runtime too, so we will also play with that. And then there's cleanup command, which just deletes that registry key. That registry key by default doesn't exist. So if we want to go back to kind of normal after emulating this test, we would run the cleanup commands to delete that. In order to run this test, we can, since there's only one, we don't need to specify that we want to run test number 1. We can say run everything from sub-technique number 2 because there is only one test. So we'll just leave it like that. And I'm actually going to include, when we run this, a timeout of 5 seconds. The default timeout is 2 minutes. There's something that I wanted to show you with this test, and I don't want to have to wait 2 minutes for it to time out. So we're going to run, if this hasn't set the registry key within 5 seconds, it will time out for us, and that will be handy in our case. So let's go ahead and run this. First, we'll go and check our registry key. Here's our HKey current user software Microsoft Office test special. If we refresh this, I'm going to push F5. We don't see any value set here, so that will change after we execute this test. Okay, it says the operation completed successfully. Let's go double check in our registry editor. I'll click in here and press F5 to update again. Sorry, we actually have to be special/perf. So we got to open this up, go into perf, and now we see this registry key set to just path atomicredteam.dll, which doesn't, that DLL doesn't exist on our computer, but we did set the registry key. If we start Word or some Office application, nothing's going to happen because Word won't find that DLL and won't run it. So the next thing I want to show you is, in the event that you run this atomic test twice in a row without cleaning up in between or without deleting that registry key, because the way, let's go look how this atomic test was written. Here I am in Visual Studio Code. I have the Atomic Red Team Atomics folder open. I'll go to T1137 number 2.yaml. And so we look at this atomic test. Line 18 is what we're executing. So if we don't delete that registry we just created and we go to add it again, it's going to cause a little problem for our emulation because it's going to prompt us to overwrite, and we won't see that message and be able to say yes or no until the execution times out. So we go back to PowerShell, and let's say we run this again. And this time it's waiting, it's actually going to time out. And we see this crazy amount of being prompted, do we want to overwrite this registry key that already exists? So what happens with invoke atomic test, the execution framework, is it spins up a hidden PowerShell window in the background and it does its thing. So it creates a problem when you get prompted in that hidden window for confirmation, like, do you want to overwrite this registry key? So it's best in these attack emulations to have things force themselves to overwrite without being prompted again, and keep this thing from hanging like it just did. So if we take a look at reg.exe, the add function, we can do /? to get the help. So when we're adding something, we see that there's a /f option to force overriding the registry key without prompting, without asking us, do you want to overwrite, yes or no? So the first step we're going to do to improve this atomic test is actually just add in a /f to the end to force it to overwrite without prompting. Let's save that. And we'll go back and run it again without doing the cleanup in between. And remember, last time it timed out after 5 seconds and then we got all those overriding errors. This time it just does it. So now we've improved this test. Now the next step to improve this would be to actually use a DLL that would execute some code every time Office started, because then we fully emulated the attack. Even though we might just start something simple like Notepad, it will be a better emulation of what the attacker would do, which would be to have their malicious code run every time Office starts. So to do that, we need a basic DLL maybe that starts Notepad, something that we can see on the screen so we know it actually worked without having to dig into listing processes or anything. So we know from our last atomic spotlight that there are some DLLs we could use in T1137 number 6, the add-ins. There was a DLL add-in that we could use there. So let's use the feature of invoke atomic test that lets us specify our own input arguments. Instead of using C path atomic test DLL, we'll use the DLL that we used last week. So if we come in here to 1137, the add-ins atomics, and go into the bin folder and then add-ins, we see a word WLL x64 on this demonstration test box that I'm on. I've got 64-bit installation of Office installed. So we need to use the x64 version, and this DLL just opens Notepad. So we'll copy the path of this. And it's named .wdll. It originally was a .dll. We renamed it to WDLL, which we needed for that atomic test. And in this case, this registry key, it doesn't care whether it's named WLL or DLL. It would typically be DLL, but we'll just leave it WLL. So I've copied that path. We're going to go back and invoke atomic test. But this time we're going to prompt for input args, which lets us, it'll ask us what we want to use for our input arguments. So it says enter a value for thing to execute, which was that C path to atomic red team. If we pressed enter, it would use that value, but we're going to paste in our DLL from T1137 that just opens calc. And I've actually run this previously, and I know that things are going to get ugly, so I'm going to prepare this command here to stop the Notepad process. Stop process, or stop the word process. So we have that handy. But anyways, I'm going to start Word, and we expect now that Notepad will open. So we start Word. And what happens is actually it opens up Notepad recursively. So it opens up Word, which in turn causes Word to open up itself again and open Notepad. And it just kind of blows up our system. So I'm going to come over here and run this stop process on Word so we can quit creating all of these Notepad processes. So maybe borrowing from test 1137.006 isn't going to be ideal for us today because it blows up our system, makes it hard to work with, and we don't really need it to start a bazillion notepads to emulate this attack. And of course an attacker would have some more control involved and probably only run the code each time Office is started, run it once instead of tying up resources on the system, running it multiple times unnecessarily. So for this, I've got Visual Studio open here, and I've got a basic DLL, and I've added in a little check using find window, and it's looking for if Notepad is already running. If it's already running, it's not going to start Notepad. Otherwise, it will start Notepad. So for this test, we want to have Notepad not running initially, but this will keep us from recursively opening Notepad and disable. So for this, I'm just going to build this, and down here in this window, it will tell us the path of our new DLL. So I copy that, and we go back into PowerShell, and we'll run that again, prompt for input args. This time we'll give our new DLL that has a little safety check in there. Okay, we've done that. Now we start Word. We expect Notepad to start just once, and in fact it starts twice, so that there's a little race condition in there that ends up letting Notepad start twice, but it's at least not going recursively out of control. So we're good to go. We've just emulated that attack. We've run our code twice with a custom DLL. Now we can contribute that DLL source code and the compiled code back to the Atomic Red Team project so everyone can use this new enhanced test. We also need to compile the 32-bit version, so let's change this to 32-bit and build that. Because if someone has the 32-bit version of Office, they'll need to have a 32-bit DLL to run to make this attack work. Which means in our emulated attack, our scripted cyber attack, we want to have a little test to know whether it's 32 or 64-bit and to set the right path to the DLL, either 62 or 34-bit. So this is actually going to be pretty easy for us because the work has already been done in this other subtechnique number 6. If we look at this YAML file, let's look at the test for WLLL execution. It has a nice prerequisite section that says Microsoft Word must be installed. That's one way we could check is if Office is installed, is assume that if Word's installed, Office is installed. So we can copy that prereq just as it is. And then second, our DLL file needs to be in the expected folder. And lastly, if Office is 32-bit, which it is if it's installed in the program files x86 folder. I mean, if it's not in the x86 folder, it's 64-bit, so we would copy the 64-bit version. Otherwise, the 32-bit. And then it would be nice if we actually started Word after changing this registry key to confirm that it worked and to cause Word to spawn Notepad. We also want to do something similar for the cleanup command. So I'm actually going to copy all of this from this test. And we'll just tweak it a little to make it exactly what we want for our new improved atomic test. I'm going to put it down a little lower so we can keep track of what's new and what's old. And I'm going to erase the input arguments. I don't foresee that a lot of people are going to want to swap out their own DLL. If we find that's the case in the future, we can add it in, but just to simplify. So let's see. We're going to take our regadd command and paste it in here. Of course, we're going to have to update the thing to execute for 32 and 64-bit. Let's go over here and create a bin folder here to put new folder to put the DLL files that we're compiling. Let's see those compiled here. So this is the 32-bit. So we'll come over here and paste this into our bin folder. It doesn't let it do it there, so we'll go back here to 113602. Go into the bin folder, paste it in, and we need to make it clear that this is the 32-bit, so we'll say x86. And then we need to go back and copy the 64-bit. So we copy this. Here we've got our two DLLs. Okay, we put that in there, and then we say office test x64.dll. And in the case of the 32-bit, we say x86. So we got that. So we just want to start the process WinWord so we can see that Notepad starts, confirm. Then for the cleanup, yeah, we'll stop Notepad and WinWord. Sounds good. And then we'll remove that registry key. So we don't need the sleep. But we want to remove this registry key. Let's see. Yeah. Actually, let's copy it from what they had up here. Sorry, gotta go back. We do need this WinWord application because we're using it to decide if Word is installed in the x86 folder or not. So we got that. So then we stop Word, and so that we can start it again and look for Notepad. So let's go with that. And we're using PowerShell in this case instead of command prompt like the other test did, because it's just so much easier to do things like figure out where Microsoft is installed, for example. But from PowerShell, we can still use the reg. We can still use the reg commands. But here we'll use PowerShell to delete that registry key. So we do that. We don't need Notepad and WinWord to be stopped for sure, so we don't need to sleep the 3 seconds. Okay, let's see if we've done everything. We've done the delete and the add. Now we can combine this all together. We've got our dependency here that says Word must be installed, and we just copied this code for determining that from the other test. And then we also need the DLL file. And we need to make sure that that DLL file is in our 1137 number 2 now, our bin folder. And we just put it right in our bin folder. We didn't put it in an add-ins folder because it's not an add-in. And we called it Office Test DLL. So we're making sure that exists, and also Office Test x86 .dll. And if it doesn't exist, we will download it into that folder from Red Canary's site. And this is kind of tricky because we're just predicting in GitHub where this file is going to be, even though we haven't uploaded it there yet. But once the pull request is approved, it will be in this location. So we'll make sure the bin directory exists. Then we can update this with Office Test .dll. Okay, those are just to invoke web requests that will download it to our bin directory. Let's get rid of add-ins. And I also spelled test wrong, or I got 2 T's here. And we also need to be going to the O2 directory on all of these. There we go. That, whoops, I shouldn't push enter. Okay, that should mostly do it. Okay, we'll make sure we have our DLLs, both x64 and x86. If not, we copy them from online into our directory, and then we test if we're 64 or 32-bit, and we set that special perf registry key to either the 64-bit or 32-bit DLL, and then we start Word to confirm. Let's give it a shot. We don't need a prompt for input arguments because it's all hard-coded to the DLL we want. It identified it as 64-bit Office, and we have a couple instances of Notepad here. Let's test the cleanup, which should stop Notepad WinWord and get rid of that registry key. We see Notepad go away, Word go away. We can check the registry. I'll press F5 to refresh. Oh, it didn't delete our registry key. So let's go look at our cleanup command. We said remove item, error action ignore. Let's get rid of the error action ignore because maybe there was an error and it didn't work. So we'll save that. Run the cleanup again. It says that registry key doesn't exist. Oh yeah, when we converted this from using reg delete to a PowerShell command, we have to specify the registry hive differently. HKCU colon is how you specify the HKey current user registry hive using PowerShell. And since our executor here is PowerShell, we need to make sure that all of our commands work in PowerShell. So I didn't properly convert that. Let's try that again. Check that the key went away. Yep, it's gone, the perf key. Let's run cleanup again. This time we get a confusing or kind of a concerning error. It says we can't delete this registry key because it doesn't exist. But really, we don't want to be bothered by this. We're just running cleanup. We just want to say if that key is there, delete it. If it's not, don't bother me with it. That's why we add in the error action ignore once we know it's working. So we can run cleanup over and over again without getting errors that don't actually concern us. And we can go back and run cleanup over and over again and not get errors. So everything looks good. We've just updated this test to be a lot more robust. Now let's create a version of this. We mentioned that you can either perform this technique using HKey current user registry hive, which does not require admin, or we could do it in HKey local machine, which applies to all users, not just the current user, but it requires admin. So let's put in our next test. We need to specify, let's clarify in the description what we're doing here. So we'll say this one is HKCU, the current user hive, and the second one we're adding. Let's add extra space here. That should be back here. This one's going to be HKLM for local machine. Since this is a new, we're not modifying existing tests, we're adding a new one. We want to erase this auto-generated GUID because that will be assigned by GitHub when we contribute this new test through a pull request. Okay, so the only difference here is we're gonna do HKey local machine. And here we have to put in LM. That should be the only changes. Let's go try to run that one. If we show the brief details, we should see 2 tests now. HKCU and HKLM. So now we want to specify a test number of test number 2 and try to run that. But we get error access denied. It starts Word, but we get the error because, of course, we knew that we were going to need administrative privileges. So let's update our atomic test so that people know we need that, administrative privileges. So here we say requires elevation. Set it to true. If we go back to PowerShell, if we ask it to check our prereqs, it will tell us that we need to be elevated and we're not. Unless we did it wrong, which apparently we did. Let's search here for elevation and remind ourselves how we're supposed to specify elevation required. Oh, requires elevation. Wait, that's what I wrote. Oh, elevation required, true. So I wrote it backwards. And try that again. So it's checking that Word is installed, it's checking that we have those DLLs, and it's checking that if we need elevation, we have it. So here it says prerequisites not met, elevation required but not provided. Now the test has been updated to say that we need that. We'll right click here, run as administrator, and let's try this again with elevation. So this should be able to set that registry key. It'll start Word, and then we'll see 1 or 2 notepads start, but we don't. So let's go see if we can figure out what we did wrong in our test. So HKey local machine. Here's the perf key, and it is set. Office test x64, and it isn't working. So maybe setting it on the local machine doesn't work as advertised. Let's review what MITRE had to say about it. It says HKey local machine software Microsoft Office special perf. And we just set it to that same value that we did before. Well, that didn't work for the HKLM. So I can't show you that. I don't know if it's because this is Office 365 and it works different. I don't know if Microsoft changed and there is no HKLM version. If I get it working after the spotlight, I will go ahead and contribute it as a second test. But from the way it's looking now, we set the same key but under HKLM, and it didn't cause Notepad to start. So currently it will say this isn't functioning. Stay tuned for more information on that. Hope you've enjoyed this little rendezvous into code persistence using a built-in Microsoft Office feature intended just for testing, but utilized by malware for code persistence. If you'd like to learn more about all things Atomic Red Team and attack emulation, check out my 2-day course called Attack Emulation Tools, Atomic Red Team, and More. from Antisyphon Training.